Okay, good afternoon once again. I see some returning folks and a few new attendees here. Margie just finished another session about the Hudson River Field Station, and we are continuing our Hudson themed afternoon for Lamont's virtual open house. Thank you for joining us. So if you're joining us for the first time, and you're wondering what Lamont is. So we are an earth science research institute that is located in Palisades, New York. And we were founded in 1949. And our first director, Doc Ewing, really wanted to open up our facilities to the community, to our neighbors, to students. And that's why he started Open House many years ago. We're proud to continue this tradition in a virtual format this year, our first ever virtual open house, and we're going to bring our science to you. And today is really exciting. As I said, we've been focusing on the Hudson, and Margie Turin is the ultimate expert on the Hudson River estuary, and she's going to be facilitating the session along with two high school educators who have worked with Margie for many years in a variety of Hudson River outreach events. And you're also going to hear from them about how they have incorporated a lot of this content into their classrooms. So Margie, I'll let you take over. And Tom and Brian, thank you so much for joining us for this.
Great, thank you so much, Cassie. So my name's Margie Turin, and I'm a Director of Educational Field Programs at Lamont, and also spend a fair amount of time at our Hudson River Field Station, which was newly christened about a year ago. It's really been there for many years. So we've sampled down at Piermont and spend time in and out of that building in many different states of repair, I should say, for the last 20 plus years. And in fact, both Tom and Brian have been working with us and with me for probably close to 20 years, if not more than that. I hate to say that. We were all really young once, but we have this wonderful a kind of a kindred spirit. I was saying to Tom yesterday, where we all feel that the river has a lot to offer, that it's a wonderful classroom. And so we thought it would be really fun to bring some educators together with us today to kind of talk about how they use the Hudson in their classroom, how they work with us in sharing this education piece with their students. And I'm going to start by letting them introduce themselves and where they teach. And then we're going to show you about 5 minutes of just slides of the students down at the river doing sampling in various parts of what we do. So just to kind of set the stage for you a little bit. And maybe I'll start with you, Brian. Do you want to introduce yourself?
I teach at Tappan Zee High School in South Orangetown Central School District. We're located right near the Tappan Zee Bridge, well, Cuomo Bridge now. And I've been teaching this is my 33rd year teaching, 26th year in the district. I teach AP Biology and AP Environmental Science, but I've taught regular bio, living environment, chemistry, earth science, astronomy, whole bunch of stuff.
Wow. Great, thank you. And Tom.
Yeah, hi, Tom Mullane. I teach at Pearl River High School, also in Rockland County. I am in my 22nd year of teaching at the high school. I currently teach AP Environmental Science like Brian, and then we have a Marine Science and Hudson River Ecology elective. Both are mostly populated by juniors and seniors. Like Brian, over my, what now looks like a long time teaching, I've taught 8th grade science, I've taught Regents Earth Science, I've taught Regents Biology, now called Living Environment.
Okay, so tried and true teachers here, which is what I love. I'm gonna share my screen and I'm gonna run a video. I put some music to it, which was not working originally and now it's working. So I just wanna make sure the music goes before we get too far into it, because that's the fun of all this. We're gonna sit back and enjoy some time at the Hudson for a few minutes, and then we'll be back and have a conversation.
sailing up my dirty stream. Still I love it, and I'll keep the dream that someday, though maybe not this year, my Hudson River will once again run clear. It starts high in the mountains of the north, crystal clear and icy trickles forth. Just one floating wrapper of chewing gum, dropped by some hikers to warn of things to come. Sailing up my dirty stream, still I love it, and I'll keep the dream that someday, though maybe not this year, my Hudson River will once again run clear. At Hudson Falls, 5,000 honest hands working daily at the GE plant. 500 gallons of waste a day. Why should we do it any other way? So I say, sailing up my dirty stream, still I love it, and I'll keep the dream that someday, though maybe not this year, my Hudson River will once again run clear. Down the valley, 1 million toilet chains find my Hudson a convenient place to drain. But each town and village says, who, me? Do you think that sewage treatment plants are free? Sailing up my dirty stream, still I love it, and I'll keep the dream that someday, though maybe not this year, my Hudson River will once again run clear. Out in the ocean, they say the water's clear. Oh, but I live on the river here, halfway between the mountains and the sea. Tacking to and fro, this thought returns to me. So I say, sailing up my dirty stream, still I love you, and I'll keep the dream that someday, though maybe not this year, my Hudson River will once again run clear. Sailing up my dirty stream, still I love it, and I'll keep the dream that someday, though maybe not this year, my Hudson River will once again run clear. My Hudson River will once again run clear. My Hudson River will once again run clear.
Okay. I think that the music is going to stop now. So thanks for indulging us and letting us just kind of show you what the students do. And I would love to ask these guys if they recognize what year some of those pictures were from, but I'm sure they would have no idea. Quite an assemblage over time. I wanted to just say a minute about why I picked the song that I picked. So it might seem like a weird song to use to talk about trying to encourage students to go down to the river. But I want to just direct your vision to the picture that is staring at us with looking at the Hudson, the watercolor of the Hudson. And I think that's perhaps one of the biggest things that we have to overcome when we take students to the river, is that they think the river is just dirty because it has that really interesting color to it. And I think all of us feel that if there's one thing we want our students to take away at the end of the day, is that that is not a sign of dirt, that's a sign of productivity. So all of that wonderful mix of sediments and plankton and salt and detritus, these little organic pieces, all of that is what makes the Hudson such a wonderful nursery area for young of the year fish. And it's just such an important take home for them all. So something you can't really teach them until you get them there, which is, again, part of why I wanted to play this. Another reason I wanted to play this song was because it brings together the role of humans as polluters, as well as puts them in charge of trying to be those people that are stewards and take care of the river itself, which I think all of us probably share as a common directive. And then lastly, we're going to talk a lot about Day in the Life of the Hudson and Harbor, which is a program that we've worked together on for many, many years at Piermont. And one of the founding fathers of that program was Steve Stan. And Steve Stan is one of the members of the group that we just heard. So he is a big part of Betty and the Baby Boomers, which is the song that we just listened to. So all those reasons were what was behind my choice. And now I'm done talking, and I'm going to turn it over to you guys, and we're going to just do some Q&A and see, kind of get you a chance to really share a little bit about why you think that participating in programs that are field programs are so important. And maybe we'll just start by a few minutes of explaining what Day in the Life of the Hudson and Harbor is. It has different parts, and maybe you could take different pieces to talk about. Brian, do you want to start? You wanted to? Sure. Go ahead.
For me, the day in the life is really getting students out to the pier. We take all of our samples off the Piermont Pier, and it gives the students a chance to actually do the science and be scientists for a day. And it's set up so nicely because they get a chance to go through all of the different parts of the sampling. I've been mostly associated with the chemistry sampling and the physical systems. So we will throw an orange into the river and they'll time and see the current that's there and compare that with the tides. And then they'll be looking at dissolved oxygen, which in AP Environmental Science and AP Bio is throughout the entire course that we talk about it. We come back to it in the spring. So they actually have a chance to use the chemistry right then and there and see what it's like, and then see how it affects the living organisms, which is another part of the day that they'll rotate around to. And then Tom can talk about that. But we do lots of different things to tie everything together. And I think that's one of the best things about the day, is that we're able to do so much in so little time. And then it really takes us weeks to deconstruct. And we'll talk about that later.
Great. So Tom, you want to chime in?
Yeah. So much of the same. When back in like 2003 or whatever, when it was first kind of pitched as an opportunity, it was called Snapshot Day, and it was just so intriguing as a science educator to hear the pitch that everyone would go down to the river on the same day in different locations and try and kind of measure and make observations of the same thing. And then we'd come away and kind of have that, not just data set, but all of that experience. And whether I knew what I was getting into or not, it was just one of those things you kind of want to jump at, because that sounds so intriguing and so interesting. And of course, it's paid off in spades. And like Brian said, the idea of, in one immersive day, having the students rotate through stations. We cover numerous labs that might have, been split up and been kind of disconnected, and that the kids rotate through everything in one day kind of really melds everything, that the water chemistry is affecting the organisms in the river, and there's meteorological and tides that are affecting everything else. And it's, to me, a lot about, it's a great opportunity to see all the connections, you know, even if we just split up all the individual pieces. And in both of my sciences, it's mission critical. Everything we're doing down there applies, you know, almost throughout the year, as Brian said.
So I love that both of you mentioned how important it is to see those interactions and in the different systems. And certainly the day itself, that's so cool. But I think one of the other things that's nice about this event is that it has this wonderful long-term history. And so you can actually go back and I don't know if you guys have done this. And so I'm going to ask you if you have. Have you done a comparative between different years and different results to kind of look at that piece?
I have
done it in a detailed manner, but one of the things that my students take away from it is the fact that because we're there, whether it's rain or shine, cold or windy, and some days it's a beautiful day, and some days it's not, and they come out saying, "Well, sometimes being a scientist is not that easy." If they're out on a particular day, and so they really do get an experience for what it's like to be a scientist on that day. But it would, I think this year we're definitely going to take a look at past, because we weren't able to get down to the river itself. So we're going to have a chance to look at data in a different way.
Cool.
Yeah, and like so many times where we kind of talk about as educators with the students about making predictions, I have found it's sometimes interesting to look at some past year's data before we make our visit, and then just kind of get students thinking about, you know, what kinds of species do they think they'll find? What do they think the water temperature will be like? What do they think, you know, some of the metrics we take on salinity or dissolved oxygen, you know, based on how things have felt this week to them. And it's just really interesting, you know, when they get something they didn't expect, right? That's what we kind of want, because their dendrites start dancing.
Such a good point. And I know that, you know, through the years that we've been doing this, there have been a couple that stick out to me as being very anomalous. So one would have been the year right after Hurricane Sandy. And after Hurricane Sandy, the sediments were all churned up. So we had very different sediment cores. A lot more sand came in because of the very active system and the push up from the harbor with water from the south. But also a lot of the young of the year fish had been just washed down because there was this wave that went up and then pushed way down. And so we had a very different complement of things. And so you know, the idea of doing predictions and looking at what we've gotten in the past and then suddenly, whoa, what happened? That's one, you know, really interesting phenomenon. One other year that was very unusual was 2 years ago, I think, where we had so much rain that the salt in the Hudson was pushed way down behind, you know, below Piermont. And today when I was down at Piermont, it was reading, you know, 14 parts per thousand, which, you know, was a pretty high level for our part of the river. The Atlantic Ocean is 35 parts per thousand. We tend to be somewhere between 5 and 10 in this time of year. And so we really are seeing a pretty strong salt push right now. And to think that there wasn't really a hint of much of anything in this area a couple of years ago is fascinating. And it shows how dynamic the system is, which is, again, another really fun thing.
Artie, can I add something here?
Yes.
The other thing I found that's kind of interesting, as you were talking, I just thought of it, the idea of this longitudinal study over almost 20 years. I have found that the students kind of, I use that as a little bit of leverage, maybe. They kind of see that they're part of something bigger, that all of their, you know, friends and siblings have been working on this project. And I think that gives it a kind of, it elevates it in terms of importance, where they feel like, oh, we have to, you know, we have to measure up and keep this thing going. And I think my students have benefited from that. Like when we look back a little bit, and it kind of whips them up into, oh, this is a thing.
I love that point. I love that point, and I think it's true. Actually, we have this data set. We use this data set. We use it for education, but it actually has some really strong grounding in some of the science that we've been able to do. So I know when they removed the meters that were looking at where the salt front was in the river, they were very excited that we were going to be out in the water and could help them with doing a little bit of ground truthing as to where was the leading edge of salinity in the Hudson. So, these are kind of fun things that our students are really able to contribute to our understanding of the Hudson River. And in fact, when we turned in the data the year that the salt front was pushed so far down, the fact that we had hundreds of readings that really helped to pin where it actually was phenomenal. And when I turned in the results, the group in charge at the DEC, sent me a note right away and said, "This is amazing. We had no idea that this was going on. It really shows, how this whole system is saturated. There's groundwater leaking into the Hudson." So the students really are huge contributors. I wonder if I could ask you if you think that there's a specific kind of student that benefits more. You both teach both AP as well as non-AP courses. Do you think that having an AP student doing field work or at the pier has a higher priority, or do you think there's benefits to one over the other?
The day is going to be great for both students. I think the AP students seem to get a little bit more out of it over the long haul of the year. They tend to use the numbers in the fall and then again in the spring. But the value that we have, we've had students from our E&L population go out. You've taken them by themselves.
Mm-hmm.
We've had special ed students join intensive classes, and they all get a very good appreciation for what scientists do. And it doesn't have to be, they're all doing the same stuff. That we're just, when we go back to the classroom, we'll utilize it a little bit differently. So I think it benefits everyone, but again, the AP student might get a little bit more out of it in terms of utilizing the data a little bit more.
Yeah, I would say the same thing in terms of some of the water chemistry stuff is very applicable for certain concepts that the AP students will see on their exam. However, as Brian said, and we've both experienced, sometimes you never can tell who's going to light up when you get down to the river. I have had plenty of students who did not seem strong with, pen and paper and bookwork, who really are quite inquisitive and light up and are happy to roll up their sleeves and just do stuff, and do the grunt work. And they kind of say the most amazing things or ask some of the best questions. And I think both of us would take all our classes if Margie had room on the pier. But it's just that I started years ago with the apes class, and so I've just kind of kept that going. But I would happily bring my other students at any grade level.
I love hearing that, because I think I feel the same way, that, it doesn't matter even the age of the student. We've had students that come in that work with us in the elementary school, middle school, high school, and they will attack it, as both of you said, a little bit differently. They will gather a little bit different understanding even while they're there. And their ability to perhaps use it later is different, but the memory of their experience of actually doing science and being in the field and not sitting in a classroom trying to work it out in a controlled environment, but where everything's shifting, it's a really interesting and unique experience. And it really does, I think, have value for any student. So I'm really glad to hear you guys say that. And that's going to lead me to my next question. I know that I'm curious, is there a specific skill that you think your students get out of this? Is there something that you see immediately that they take away? Is it varied? What do you guys think?
As you said at the beginning, they take away that the river is not dirty per se, and that there's so much going on. I think they get a very much different appreciation for the river, and some of them live right in Piermont, and the river is what they see all the time. So that one takeaway is tremendous. But one of the skills is just better observations, that they really have to be on in what they're seeing. Even having boats cross the their paths in the pier. That's one of the things that they should be looking for when they're looking at the physical river. And then we talk about why. Why is that important? How does that affect everything? So the observational skills are really big. And I've had kids comment that they really had to be basically on the whole day. And when they get back in the bus, they're exhausted. They are absolutely exhausted.
Yeah, I agree. And I would say kind of, you know, when I go down, I want them to be working on specific things like how to use a dichotomous key, how to use chemical test kits, how to use digital probes. But sometimes, you know, what they come away with isn't exactly what we want. They absolutely, like Brian said, it really is more like a frame shift of their thinking about the river, and in a couple of different ways. I think one of the other things that they really benefit from in the science education is some of the I don't know, like metadata stuff. Like they notice that we have them thinking about the weather and the site and how are we getting these measurements. And I think it, you know, behind the scenes of the specific tasks they're doing, I think we impress upon them that, you know, there are accepted methodologies to kind of doing this stuff, and that they're working with our science partners. And so they're shoulder to shoulder with people. And I think it gives them a kind of a, I don't know, maybe it gets out of the textbook and they go, oh, this is they really do it this way, you know? And it just, I think that finally cements it in their minds like, oh, okay, you know, I've said this before, it's a thing.
And they get the sense that they can do it, that they can actually do this. It's not like Tom said, it's not just from a textbook and it's remote. It's something that they can do, that they're playing with these gadgets that are really interesting, that they've never seen before. And they're the test kits we have in class, but they're seeing it in real life at the site, which is very much different.
That's a really good point. I know we had this conversation, a couple of colleagues and I, about, you know, pH being something that students do pH, they sample pH, they know about pH since they're in elementary school for the most part, but understanding it and what it has to do in the real world is perhaps a little bit different than just understanding, you know, what that pH neutral is 7, and right, and you can kind of go on either side of that, and setting up a starch experiment or whatever. So really kind of seeing these things play out in the real world is so important. Tom, you said something about metadata, which I really, I love that you said that, because there's another piece to this day, which I think is really important, and that is that the data is actually shared. So it's not as if they're just collecting data for themselves that they have ownership of, and they're the only ones that have to worry about it. So it doesn't matter if they write down units, and it doesn't matter if they record observations, you know, in terms of it was super windy, and that's perhaps why we had such a high dissolved oxygen. They need to kind of make note of these things. Does that really carry over? Or is that just hopeful on my side that perhaps they're understanding that?
I think they are understanding that. I think when they're there, they're seeing the big picture, especially because they're going through all of the setups that we have, the different stations, and the fact that at the end of the day, we're going over where they might have been there in the morning and gotten certain readings, and then someone else comes in towards the afternoon and it's totally different. They're seeing that change, and that's only in one day, only a couple of hours that they're seeing it. So I do think they're getting an appreciation for the big picture and that metadata that's being taken.
I agree.
You agree? Okay. I mean, that it's definitely a goal on our side, that they really see that this is one piece in a fairly dynamic system. And the fact that low tides, you know, might start in the harbor at 7 a.m., but if you're up at Albany at the same time, you're dealing with a completely different tide, is something that only plays out if you put all that data together. So, you know, again, having that bigger picture is something that we hope happens, but it's not always easy to do.
Well, and one
Go ahead, Tom.
specific way, you know, I I tend to be, as you see me in the picture on the screen, in waders and over at the seining station. You know, it's very apparent to students if it's a windy day and the net is popping or the water gets very turbid because of mixing. Then when we look at data from year to year and we see different fish catches, students have a better sense of saying, well, maybe it was something else. It's not that the fish are extinct. You know, and they have a sense of, well, we need to ask some other questions too, right? What were the conditions like? And I think just right there, that's a victory. If we get them just realizing, you know, it might not be experiment or error, it could be the variability of everything else that is affecting, you know, the data we get. That's fantastic for a high school student or younger to come away understanding that.
Good point.
So this year, I'm a little more excited about looking at the data because in the past we've only looked at Piermont, but this year, because we're not going down when you're doing it and setting out the information at 3 different locations, so we're actually going to get a good look at the entire river as a whole.
Yeah, so thank you. You know, maybe I'll just explain that a second for people that are joining us. So because of the situation we're in right now with COVID, we really couldn't take these thousands of students down and it really is thousands. Like we have 5,000 students traditionally down at the water sampling in about 105 locations all throughout the estuary and even just above the dam and just outside, so down in Staten Island area. And we share all that data, but as Brian said, most of the students will spend most of the time comparing their data to perhaps a prior year at their particular site. Maybe if we're lucky, they'll look at one other group's data at a different part of the estuary. But there isn't really the ability to kind of pull these together and frame them into different parts of the estuary. So this year, we are bringing together our partners who have been phenomenal at volunteering to do this, to go out, and we're breaking the river into 3 parts: the harbor, the lower estuary, and the upper estuary. Our piece is going to be in the lower estuary, which will start just a little bit south of the George Washington Bridge and go up to Newburgh. And then the upper will be up above that to the dam. And we're going to collect in multiple places and then pull those together and get some representative measurements till we get just a set from the harbor, a set from our section, and a set from the upper part of the river. And then the students will pull those off the videos and they'll do an analysis with us and a comparison, and they can do, and we'll have a guest scientist as part of each one of these. So they'll help unpack some of these things. And then the students can actually compare those to the other sections of the estuary that we've looked at. So it will be different. We wanted to kind of hold on to some of the pieces that we thought were really important in the experience itself, which was all about the students being involved as samplers. So we can't actually have them sample, but they're going to be collecting the data off of the instruments and doing the interpretation. We wanted to have the partnership piece, which is so important to us, and really look at the system. So I think we're going to hold on to some of the key pieces, and it will be very different. But I'm really excited to know that you're excited about it, because we think we might have hit on a possibly good solution, but you never know. Always fun to try it out. So I guess we just kind of are walking into the next question I wanted to ask you, and that is that the field experience is really important, and to us it's so central to everything. But we also have other parts that go around it. So we often will do pre-visits with you and post-visits. Can you speak to how those work in your classroom? Is there a benefit to that? Do you prefer to do your own prep? Does it work to bring somebody else in? How does that play out for you?
I always like having guests come in because students get a little bit different feel for the topics when someone else is talking about it and not just me. So I definitely have you guys come in as often as I can. But I very much like the lessons that you guys have on your website are really good. Right before we usually go out, we go through the dichotomous key. We go through the field work, the field book on that, so that they have an idea of how to use it. afterwards, we go through and we do some study sets on the data and some graphing material, but then we come back in the spring and we talk about DO and AP Bio, and we come back to that data. So it's used throughout the year.
I also enjoy having the guests come in for the same reason. And if we were all students once, we remember it was always kind of fun and exciting to have a guest speaker. There's usually an attachment of, oh, here's an expert with something coming in, and the kids lean in a little bit to that. I think for this, for a day in the life, it's really good to kind of get them all at least an equal footing with some background information. So, the viewing of maps of the size of the watershed and a discussion of, for our group, we're at the Piermont Pier, but it's important for them to know all of that water that is flowing past us in both directions while we're there, where is that coming from? So that it speaks to what we're measuring isn't just, from the channel, but it's almost a picture of the watershed and what's going on, right, with human impacts. So that's really valuable, the preliminary work. And then likewise, I debrief with them for a day, ask, favorite things, toughest things. And over the years, Brian and I have given feedback to Margie, and we kind of say, hey, what are they struggling with? What could we modify? And then we start to just, I tend to throw data up and say, let's start chatting. Do you see any trends? Do you see any anomalies? Are there patterns? Are there ranges? Sometimes they just need a little leading, kind of like just frame something to focus on. And very soon after that, they're off and running. And then we use that data throughout the year for varying things. And I too go back to the Day in the Life website and use the lessons that are there in both classes, even the class that I don't take to the river. So there are lessons on fish communities, there's lessons on locating and finding the salt front, and a whole host of things, and for varying grade levels. So you can kind of amp it up for the older kids, or simplify things a little bit. There are graphs and graphics, very accessible type of lessons.
Cool. So you mentioned something that maybe we could hit on again, and you said you asked the kids, so what was their favorite part? So I am kind of interested. What do you get back from the kids? I mean, we all know what we want them to get out of it, but it's probably not what they are getting out of it, right? Their big memory is going to be something totally different. And please don't tell me it's about a sandwich, because that's that's what I don't want to hear. But what kinds of things do they come away with as just their high points?
Always. No, they like the seining is probably the number one thing that they do. Seldom do I get someone that says the chemistry part was great, but they also do like the soil and getting the core sample and smelling it. They don't realize that there's an odor to this, and it's definitely a new experience for them. But the seining is definitely number one. They always come back, I caught this. I got a crab, I got the bass, mum and chunks. That's always a favorite of theirs, just to say the word.
I get the same results, and I've come to expect it. So then my follow-up question is, if you can't say seining, right, what are your next favorite things? Coring the sediments comes up a lot. They also like throwing an orange into the river to measure the tides. There's something still about skipping stones or being allowed to put something in that they love. I want them to love the water chemistry just as much. What I find is, if I linger a little longer, some of the other kids come out of the woodwork and start to speak about some of the other things that they enjoyed. I think there is definitely an element of the strength of our partners that are helping the kids. And so sometimes, the experience they're getting is also part of that interpersonal. If they really liked the grad student, if they really connected with the scientist helping them figure stuff out, that it would influence me too, right? It's just kind of in our nature that helps, or that has an impact.
Nobody said turbidity. I'm a big fan of water clarity myself, but so I think it is wonderful to hear that sediments are such a high-ranking experience as well. Lamont's known for its sediments. I mean, this is a piece that we actually added to Day in the Life. We brought it in because it's something that we've done for, all over the world's oceans. And it is kind of cool to smell the mud and really get a sense of whether there's aerobic or anaerobic decomposition and kind of dig in. And it's always so interesting to me to watch the students. So you tell them, well, put your fingers in and really get in there. And they're like, what? But once they do, they're in. It's kind of like putting them in waders, right? They're never sure they're going to go in, but then once they're in those waders, they want to spend the whole day in those plastic pants, as they call them. It's a lot of fun. One thing I did want to ask you both, I know it's not easy to get students out in the field. I know how many pressures, well, I probably don't know as well as you all do, how many pressures there are on teachers in their teaching day. And anytime you take them away, it means a lot of extra work on your part, as well as other people who have to step in and help with classes that you're missing. And I'm just wanted you to kind of speak to, is it worth it? Like, how does this rank in your life? How much effort do you think it's worth?
Well, a testament of us doing it for almost 20 years tells us that it's definitely worth it. And I look forward to it every year, and the kids look forward to it too. As Tom said, it's almost like, oh, we're following a legacy of students doing this. Our school's very good in promoting excursions out of the school building, whether it's to an art museum or science-y type thing like this. So we're encouraged to do that, all the teachers, and everyone understands, okay, I'm missing math class because this kid's on a science trip. That's fine, because they're going to take a math trip at some point to something. So we're pretty good at that. It is a hardship in terms of planning for me for the other classes that I'm missing, but it's definitely worth it to see the kids outside doing science.
And I kind of have two approaches in my mind when I start to feel like, oh, right, how is this going to impact time? One is that I view it as more efficient, right? There's found time in that the kids can do so many labs in the field that I won't have them do them all over again. So it's not like I've wasted time or I'm doing the same thing over and over. Just a little bit of planning helps me say, hey, check, done, right? We do the debriefing, we do the follow-ups, we do the lab reports. The other thing that has struck me over the years is that we always feel pressured for time, and our best intentions are submarined by snow days, fire drills, other teachers' trips, you name it. And so I've kind of, come back to, well, then this is the best reason for me to feel like, oh, where am I going to find the time? I'm giving the best experience to these students. I'll never feel like there's enough time. So we might as well dive in.
I love those approaches, and you're absolutely right, Brian, when you say we've been doing it for 20 years. So clearly we're committed to this. But I love to hear the articulation of that. I hadn't realized that you were able to take these labs and use these as a series of different labs. I think that's phenomenal. And that gives me some ammunition to kind of help with other teachers who are facing more challenging, perhaps administrations, or really haven't thought about or seen it that way. So that's really useful for me to hear. I don't know if we haven't taken any questions from people that are watching. I don't know if we have any questions from people that are watching, but I thought maybe I would provide that opportunity for people, unless there's something that you think I haven't asked that you'd like to make sure to say.
Well, I hope some people have questions, but not knowing exactly who our audience is, I would say if there's a teacher here who has considered doing this, this is the best opportunity. I mean, the partners do half of the heavy lifting or more. You don't have to start from scratch and create all of this stuff. You would just work on getting the right contact and then working with your district to schedule the transportation to the site. But so much of the equipment is provided, the partnering of some other expertise, the guidance, people who know the site already, and that's been a tremendous benefit. I have to do, I don't want to say very little, but it's not as a monumental a task as it might seem. The event is big, but your individual part of it is not overwhelming.
It's not, but I will say something that I think is really critical to say, and that is that you and the two of you do man a station. So it's not like a field trip where you go and turn your students over to us and we take over. Even though we do take over in terms of moving the students around and dealing with a lot of things, you are part of the day and a critical part of the day. You man a station for us. So it really is about field work. It's not like the kids go and stand back and watch something. They're fully immersed. You're fully immersed. And that's the critical piece to it. They watch you in action. You watch them in action. We're all kind of part of the same team.
Good job of training us as well. I mean, you have days prior to this, all the way in August. You start in August, training people if they want more training. People that have been doing it for a while can come, or people that are new. So it's really a good thing. And yes, you're right. I'm actually doing science also. I'm a science teacher, but now I'm a scientist that day, and it's very exciting for me.
That's such a good point. Yes. And you're absolutely right. We do workshops. And I want to just say that as part of the field station, outside of Day in the Life, we are we're set up to have these opportunities to bring classes to the pier. And I know that we have had some from Tappan Zee. You mentioned them already, Brian, from different levels of classes, different groups that are able to come out and spend time with us, and we can modify what we're doing a little bit depending on what our audience is. And we're absolutely excited to do that. We have some cool new tools at the field station. We have a three-dimensional map of our part of the Hudson River. So it shows kind of how the Hudson, the depths of it and how it moves through this part of the landscape. We have a striped bass, which was donated to us by our fishermen up in the Newburgh area, the Windsor area. And it was already dead and ready for us when we got it, but we love having it because it allows us to really showcase a real specimen and be able to talk about it. It's pregnant female striped bass, which lets us talk about the history of striped bass in the river and how important they are both at a commercial level and a recreational level now, because we can't commercially fish them. So again, we have a variety of different things we're bringing in. We have a tree ring that we're getting put together, and the story behind that. We're getting a core sample that we're going to put together with an exploration, which will which will be on the walls. So we have some other things that we're bringing in, and we're really looking forward to turning this into a full learning environment, which is pretty exciting in and of itself. Do have one question. What are key thinkings about salt front change over those few years? Now, can I toss that to you guys as teachers who've been with me for a long time? You want to weigh in?
It's very dependent on the rain that you get prior to us going in and sampling. And so, as Tom said, we asked for predictions, and that's one of the biggest predictions I asked for. And what do they think the salinity is going to be based on the last couple of weeks weather that we've had?
Margie, you broke up a little bit reading the question. I didn't hear everything, but I know it was about the salt front.
Yeah, what are key thinkings about salt front change over those few years?
Oh yeah, right. Prior precipitation, we go in the fall. Sometimes, as you mentioned earlier, there were hurricanes that came through. There's, surges and more mixing of the water.
Yeah, you guys are great. You're great students. The one that was the most anomalous, which I think I mentioned already, was when the salt front was pushed way, way, way down past Piermont. And that was not only a function of recent rain events, but actually we had an extraordinarily wet year just in general. And so the ground was so saturated that any amount of rain that fell was going to go right into the river. Nothing was getting absorbed in the watershed. And the watershed was so saturated, it was leaking fresh water into the river just on a daily basis. So the salt was just not making its way up because there was just such an outflow of all of this strong rain event. So you guys are amazing. You know everything about the system, which is great. And you know, that's kind of a fun thing for the students to really gain an understanding of that dynamism and how variable things are. And so the fact that, you know, once you measure it once, it's not as if we understand it by any way, shape, or form. The other thing that we have in the Hudson itself at Piermont is we have a real-time monitoring station. So we have water quality and we have weather station down there. And so, you know, sometimes students say, well, why are we bothering to do this? You have a water quality, you know, real-time monitoring. What do you need us for? But, you know, every instrument you calibrate, and we like to ground truth everything. And I think it's really important for the students to collect that data and then do a comparative. The other thing that's a little different is that that sand is stuck way further down in the water column. So we tend to do a surface sample nowadays. Although you can see in this wonderful picture of Brian that he has a Niskin, so that allows us to sample further down if we want to. But being able to do a comparison between the water that's a little deeper than water at the surface, we will find differences in temperature and DO and salinity. You know, we have that opportunity to kind of look at that. So that in itself is pretty fun. Are there any other questions? Or Cassie, where would you like us to go from here?
I think you've done such a great job, and I want to. I think we can wrap up. I would say, if you, Margie, if you want to share the website for the Day in the Life event, and if Tom and Brian, if you want to share any additional links or any lessons, you know, you can. We can either follow up with this group, but if you could, Margie, whatever you have right now in the website form, you can share in the chat box so our attendees can see. Yeah, and if any of our viewers have any additional questions for Margie, Tom, or Brian about resources, about what they've done in the classroom following the actual event, feel free to get in touch with us. And yeah, I want to take this chance to also thank you, Tom and Brian. I know it's a crazy semester, which is the understatement of the century. So thank you so much for taking the time from your hectic school schedules to do this, and really appreciate that. And Margie, thank you for giving us all the opportunity to do this with this wonderful event. And good luck tomorrow during Day in the Life, the virtual version.
Thank you so much.
Yeah.
And yeah, thank you, Tom and Brian.
Yeah.
Okay, thank you.
Yeah. Have a great afternoon, everybody.
All righty.